Now it's going to be recording. Perfect. So double click any of these viewports, which are 4 in total, and it maximizes, right? Once you're maximized, there are 4 tabs on the bottom that you can also click to switch between the viewports individually. But let's stay in the perspective for now, and let's forget about what I was saying earlier, that we usually have a black and white method of looking at a side view, at a top view, and then whatever other view to compose our objects, where we could be in 3D all the time. I mean, why not, right? We do that in SketchUp. We can do it in any other program. And I say that because Rhino is more CAD oriented, and usually CAD programs are, you know, orthographic, and you have elevations and plans and everything. So let's start by manipulating a little bit of the Rhino interface. With your right click, leave it pressed, and you're able to orbit around the grid. That's the primary, you know, operation that you do in Rhino, is being able to navigate everywhere or orbit, you know, below the grid, on top of the grid, and just pretty much stay hovering above or below the plane. Now, if you leave the control button pressed and the right click pressed at the same time and move the mouse back and forth, you start seeing a little zooming option. You see it, press control and the right click and move the mouse back and forth without letting go of control nor right click. Okay? And remember, this will be recorded, so you can go over it. If there's time, I'll add captions and subtitles. If not, then just listen well. But so yeah, zoom in, out, control right click, don't forget that. Navigate, zoom in and out, right? Then if you press Alt, leave it pressed, and you use your orbit button with Alt pressed, it switches to the same option, okay? But if you press both Control and Alt, you have a little bit of a different camera manipulation. So you can just alternate between Control by itself, Control and Alt, Alt on its own, and ultimately, well, you have the regular middle mouse button that lets you scroll as well, similarly to the Control, just less smooth, okay? So with that said, you know how to move around, and we also can press Shift and the right click to pan around, right? Side to side, back and forth, kind of turning motion, whatever we want to do, and then orbit, and then move, and then orbit, and then move. Let's say that we're always trying to look at the center of the grid. So we orbit, shift, move, orbit, shift, move, orbit, shift, move, and then we start working out our muscle memory there on our fingers to just not forget how to move around. That ends up being a big problem when we're beginners. You know, how to zoom in, how to zoom out. I lost my object, I can't find my view. Stuff like that usually happens in any software. So with that said, let's zoom out with the middle button as much as you can until you don't see the grid. Let's say there's a little model where the grid is, and now you've lost it, and you don't know where to zoom in. You're just scrolling anywhere. So we can't really get lost if we type in this next command. Zoom, pretty straightforward. Leave it there, don't press enter. You see a few options, okay? If you select zoom ends, nothing happens, right? It says nothing to do. Select some object to go to the end of that object or whatever. Okay, so if we can't do that, then there is an option, zoom, enter, and look at the, now when we press enter, the zoom option has sub options, right? Inside the parentheses where we can choose extents and no objects are visible, right? So we have a problem where we do zoom and I can't find anything because there's nothing. So if I go to all, nothing, nothing, okay, extends, one-to-one, I can't find anything. So the trick to do here, which helps us immediately relate to the grid in Rhino, is, you know what, I'm gonna draw a point because I can always find the point that's at the start point of everything, right? Let's just type in point. So you type in point, enter, and it's going to ask for a location. Location meaning coordinate, right? X, Y, Z. So let's just say 0. 0, enter. It already made the point. We're just very far from the grid. We haven't found it yet. But now we have something created. Therefore, we have options. We can select all being just one point. Or we can select a point with a command, select point, which is abbreviated in cell PT, SEL-PT, cell point. So let's try any of the two. Let's do Control A to select all, just like any program. Control A, and it says on the command bar, 1 point added to selection. Type in zoom, enter, and then type in S for selected, enter, and it'll take you right to that point. Now you've found your grid again. You can orbit again, zoom out, zoom in, and get lost again if you need to, and come back, because now you have something to anchor to. Obviously, if you delete the point, then you don't have anything, but we usually don't delete our models. Great. So now you can find your grid if you're lost, and you know how to create a point. And a point has coordinates. In this occasion, we used 0. Perfect. There is a, bless you, there is a menu ribbon, obviously, over here, that we could go if we want to create a curve, we want to create a surface, we want to make a solid or a mesh, etc., etc. But like I said before, we're focusing on knowing the commands. And in fact, I'm going to increase the font there. It might be too, not very legible. So. The what? Oh, no, I will. We just haven't made any objects. Okay? You haven't gone back to it? She can help you. In the meantime, yes, I was going to say that. Go to options, enter, and in my case, I'm going to change the appearance of the text because you guys might not see it very well, but you can practice. So right on the left, we have a menu of things, many things, and I'm only going to look for appearance right here. And as soon as I click the first of the options, I can find the text size, which corresponds to what's on the command bar. And I will change it to maybe a 13 for now. You guys can see it a little better. And I'm going to go back to options. Notice how I didn't type it in again. I just hit the right click on the mouse and it repeats the last command. You can also do it with enter or the space bar. Okay, once again, once you're in the options and you find appearance, if you need to change anything, change it. I will just change the font size and the background of the command bar so that you guys are able to see it. Therefore, the text, I will change it to green. So it's really contrasty. Make it just slightly bigger, 15. That's the size of the text. And I'm going to drag the command bar a little bit down. And just to be completely on the same page, I want you guys to also close all the clutter inside of Rhino, and I will show you how. Any bar that you see, any menu option, you can drag it out, just like I did there, and then close it. Simply try to drag all the menus except all of this bottom ribbon that we have here with the views and these little squares. Just leave it the same way I have it because it'll be just, sure, you can leave it. You can close it and then type in layers or layer and it'll come back up. So pretty much leave the 3D view and the command bar somewhere floating or on top or snap it to the bottom wherever you need to have it. But really start by decluttering the interface. Most programs come with a bunch of options and that's the first thing they show. And then we have to pick our preferences. So in this occasion, let's just stay in 3D and look at it as that, right? 3D space. Get rid of all the toolbars and leave it stripped of that clutter.
What did you do with the properties? What did you change?
Oh, I changed my font size and my background for the command bar, just so it's more legible. You can do it if you want to. Okay, now let's, well, again, because the first thing that shows up is our grid, let's come back to it and relate to the grid by typing the command grid, enter. Oh, I didn't type it. Grid, enter, and just make it a habit to look at the options inside the parentheses all the time. It says snap spacing, minor line spacing, blah, 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 the extents, whether you want to show it or not, whether you want to show all the information, right? So let's just say that we want to keep the grid, cool. It has some value, extent value, as a default. Whatever shows up with you guys, just click where it says extent and choose 10 and then press enter. So we have an extent of 10 units. We don't know what the units are yet because we haven't set them. Probably by default, they're millimeters. So that's 10 millimeters over there. Cool. So the grid command stays open for us to either show it or not show it. Okay. But what I really want you to notice here with the grid command is that every option inside the sub options, the parentheses, has a little letter highlighted or underlined. So for snap spacing, S is highlighted, right? For minor line spacing, M is highlighted. So there is a shortcut within the command to access those options. So if I want to go to extents again, I press E, enter, then enter my extent value, let's say 20, enter. I chose to hide the grid, so I'm going to click yes on show, or remember, H, enter, that's hide it because I went to the show option, H, enter, H, enter, H, enter, H, enter, okay? So show or hide, cool. With that, we know how to manipulate the grid, and we also see the option to show the grid axis, which is O. The letter O is underlined, so if you hide the axis, you don't see X and Y, okay? It doesn't hide the Z axis, that is accessed differently. But once again, bring the axis hidden or turn them off, then bring them back on, the grid and the axis, get used to that. Sometimes the grid is annoying, sometimes you need it. Cool, so we have the axis showing and we have the grid showing. We've chosen a different extent. We're experts at understanding the grid and creating a point. Cool, so with that said, let's go back to the keyboard here, hit escape so that the command is deleted. Yes? What is it?
We don't have the Z yet.
Oh, your guys don't have it. Okay, cool. I think Rhino by default doesn't show it. So type in layer, enter. Once you're in layer, there's a little tab next to it that says display or somewhere there. If you don't see it, do you see it?
No.
Okay, then right click the little gear and find display and make sure it has a check mark. Once it's on, scroll all the way to the bottom and find Z axis and check, put a check on it. Then you see the Z axis. Cool. So, and you enter the grid options through that tab as well. You can hide the grid in this particular viewport. You can hide the C planes or the X and Y axis, and you can hide the Z axis or the world icon, which is all the way to the bottom left, that tells you and indicates where you are in space, right? In which direction you're moving. So yeah, in fact, we can leave this box open if we want. Layers and display are usually something we come back to if we want to create more layers and stuff, which we will in a minute. So obviously, yeah.
What is snap spacing, minor lines?
Oh, okay. So that means how the spacing between all these squares. So right now they're every 1 unit. They could be every 10, every 5. So it's just the spacing of your grid, which I didn't get into, but I mean, we could, right? Make the grid bigger or smaller. It doesn't really influence unless you're using the grid to build off of it, like snapping to it, which I don't think anyone does. But you could, okay? And because you can, let's click on Grid Snap all the way to the bottom. There is a Grid Snap next to Ortho to the left. It's the first one of those little tabs. Once you click on Grid Snap, now run the point command, point, enter, and you'll see that it begins to anchor or identify magnetically, right? Point on the grid. So that is grid snapping, if you want to be exact. Cool. And there is also, well, that's pretty much all there is to it, to grid snap. So hit escape and the point goes away if you haven't hit enter after setting it up. And you can undo grid snap by clicking on it. Every time these buttons on the bottom are bold, then that means they're on. So make sure that we know that. And now we get into some geometry manipulation. We know how to create a point, so let's get into a primitive, right? We want to create a primitive, the easiest one, maybe a box, right? A cube, a rectangle. So let's start by just typing in box, enter, and we're gonna get options. I'm going to ignore my options because there's a point already on my mouse here, my cursor, already.
At the bottom, you was in here, point, INT, they're all selected. Mine's not. Is that important?
Not yet, but good question. Yeah, that's part of your snapping if you want to snap to points and other little components of the geometry. So we have the box activated, and it's going to ask for a first corner, and then the other corner, and then a height. Okay, I'm doing it freely. I'm not paying attention to units or scale or proportion. I'm just getting familiar with how to create an object. Once I decide on the shape, I click again and it's made. The object is made. And if we are not looking at its actual surfaces, it's not shaded, right? It's all wireframe. Then we need to get into displaying the surfaces of the objects by right-clicking the name of the viewport, the little tab, and then choosing shaded, or choosing rendered, or choosing ghosted, and so on and so forth, right? The last ones become heavier because they're actually being rendered real time. If we choose ray trace, the object will get rendered, and if you move, it'll start over, right? So be mindful of this particular viewport. It could crash if you have a lot of geometry in the viewport because it's going to try to render it real time. But we have Arctic view, which is very similar, and it makes the objects look nice, and you have nice shading. Good. So let's go back to ghosted view. Traditional ghosted view. Do you guys see some lines crossing the faces of the box, passing through, or is it just like mine? And what I mean is your object showing isocurves? Nothing, right? There shouldn't be any. So, and what I want to explain there is that we have a box here that is made of 4 planar or flat faces, whereas we could have a box made out of an extrusion. So please type in the command rectangle to initiate a rectangle curve, and it's going to ask you again for 2 corners. This time, though, you don't have a height to put in. So you just draw a rectangle. And I never mentioned the gumball, which Selena was bringing up, but I think it was pretty evident that as long as I select an object, the arrows show up and I can move them. You know, it's. I'm counting on you guys seeing some of that, but there are options inside of the gumball that I will discuss. Okay, so you have your box, you have your rectangle. You can click on any of the 2. You see that the points are highlighted, control points to deform things. We're not deforming it yet. We want to familiarize with 2 ways of recreating that box. One through a command, one with the gumball, and then move away from this first demonstration, okay? So part 1 is to duplicate this rectangle so we have 2 rectangles to work with. First way to duplicate, Control-C, Control-V, like any program, okay? You can copy and paste geometry. You can copy and paste one geometry from one Rhino to another if you have 2 open. So very, very useful, but it shows up right on top of it, right? So click away from it and then click on it again. Immediately you see two options, selection menu. So another thing to always remember in Rhino is that if you have things overlaid, it will ask you what do you want to select, right? And sometimes it gets difficult because they're on the same place. So I don't know which one is which. I just have to try. Okay, I grab one, move it away. You have one and you have two. So let's work with the first one. The first one selected. Zoom in a little bit and start dragging it up slowly as if you were trying to just slowly see how it moves, right? Up. But as you do it, press Control and leave it pressed and you start noticing a line that is being drawn from one corner to another, indicating that there's an extrusion going on. Let go of both Control and the mouse and you have a box. But it's not closed. You do it?
Yeah.
Great. Awesome. But again, it's just an open object, right? Made of multiple surfaces. Okay. The second one is the same rectangle, but this time we're going to choose the command extrude, which pretty much any 3D software has. Extrude curve. CRV, abbreviated for a curve, the rectangle being a curve. Enter. And you have the option to go up or down. And let's just move it up and identify if you're able to anchor to the heights or of the other ones. If you're not being, if the smart track isn't working, then go to the bottom ribbon, select first of all smart track, make sure it's on. Okay, go to point, leave it on. Okay, at least point should be on.
Wait, where'd you go?
Right here. Has to have a check mark. Okay, and also for end, to identify the extremes or the ends of objects, right? The end point. So with that on, now we can identify with the smart track something else to guide the extrusion here to. So we can orbit around, practice our panning, move to the other side, reposition the object, look at where we are going with this extrusion, and find our point. Click there and finalize the extrusion, which also yields a open box. All right. So as long as an object is unified at the edges, a poly surface, meaning that there are multiple surfaces joined together, right? Because this could be exploded into individual segments. So once you have 4 of these, or as many as you have, and you have flat openings, as long as they're flat, meaning planar, right? Not in a curve or anything, you can always close this object if you need to with the command cap. So you put a cap on it, cap, enter, it's gonna ask you to select an object, right? Or you could have selected it before and then hit cap, right? So pick any of the ones that don't have the cap and then hit enter and it'll close it. Okay, now that's the difference between a just flat extrusion, polysurface, versus an extruded object. An extruded object will show you these lines passing through, defining the phase in the middle of the axis and whatnot, because that's showing a transition from the curve you got pulled up, and that's just its data, right? Versus I just made a box. So Rhino is very redundant because the geometries are the same. I mean, you look at the rendered version, it just look like a box, right? So it's just a way for you to know what you're doing and what you're working with. Perfect. So we know how to close an object and we know how to extrude any curve, quote unquote. We only made a rectangle, but we could have a circle, right? And do the same. So now that we've done that, let's grab this closed object, put it to the side on the y-axis or the x-axis, wherever you prefer. You'll notice that the original rectangle wasn't deleted. So that's another thing to keep track of, whether or not you get rid of your stuff as you model. Okay? This object over here that is selected is a solid by nature because it's all closed. And it has control points that are accessible through the command solid PT on, solid points on. Enter. The points show up wherever there is a point. Yeah. Select the object, solid PT on, solid points on. So turn the control point on for the solid. Once they're on, it deselects itself, but now you can click on the point, right? And move it slightly downwards, and you'll see a slight deformation of this poly surface, which is no longer a box, right? Now it's a poly surface. It's curved on that surface on the top, so it has completely changed its quote unquote morphology, right? It's no longer just that extrusion. So same goes for any of the other points which are editable, right? And that's a way to manipulate geometry really easily as a volume. Let's say, or imagine that this is a building that you're creating, and you, for some reason, need to have a kind of like a cantilever option here, right? I've seen some buildings in town, some of them from ASU, downtown Phoenix, that have this kind of accent going on. So to picture that fully, let's grab the command line, enter, and let's click one of these bottom corners where the opening or the deformation that I just did, if you guys copied it moving upwards. No, I just clicked, typed in line, enter, and it'll give you a bunch of options. Let's ignore them for now and just respect the first of all of them that says start of line. Okay, this is my start right here. And I'll zoom out just to show you that there is an extension of the projection of the line through the smart track, right? Which helps you guide what you're doing. So without doing the second click, without drawing the line, we have that first drafting option. So let's pull it just enough and then move without clicking, leaving the mouse right on top of the other point, wait for it to highlight so it turns white, and then you have two guides. You just have to pretty much identify the points. Okay, go hover over that point. It's white. Okay, now it's highlighted. Go hover over the other point. Okay, now I have guides everywhere, right? So I have this line that can be created all the way to where I have the projection of the other point and click there. So I'm true to this shape. And I do the same from this with the line command again and go back. So it's just two lines. I will do it again, yes. And that's the whole point of this, introductory tutorial, that we grasp these basics. So once again, you have a deform object. The points don't. Okay, don't worry about it. Hit escape. No points are on. Doesn't matter, because all you need to have on is end and point, so that you can identify the end or the corner, right? End is the same as corner for an object, right? So now run line, enter. The command is active. It asks for a start point. So click on one of the bottom corners. Okay, extend that line out without doing a second click. And while you're extending it, go look for that other point, just hover over it, place the mouse on it. Wait for the highlight and pull it across back to where you were drawing the line, so you find the intersection of those two projections. So it's pretty much moving your line before you draft it, right? I'm deciding where it'll be, and I'm using this smart track projection to draw things. Right now, very basic, but it comes in very handy.
So it didn't give me the second job.
Okay.
But it's highlighted, but it didn't give me.
Okay, you were able to draw the first line
Yeah,
like that?
yes.
Okay, so then you run the command again, line again. Okay, but now it's very easy. Now you click here and you click there because you already know you were using the guide. Right?
Yeah.
We'll do it.
But
Let me see. Yeah, perfect.
yeah, I need this.
There you go.
Yeah.
Maybe reposition your view.
So if it's not like snapping to something,
And then wait for it.
like it's snapping to that corner, maybe try this one. and come down.
Another important one, guys, if you pause for a second, is maybe you can't do it because of this. Intersection should also be on. Int. That way it finds where those projections intersect.
Oh, okay.
But what's also important, and he was having this problem, is the following. So if I'm trying to find those projections here, we'll treat it as you looking at it, right? I can't really see it. So Rhino can't really project somehow. Or you don't know where you're projecting. But if you reposition your view to somewhere where you can identify the objects that you're trying to anchor to, then it's easier for you, okay? Easier for you to find the things because you can see them, right? Perfect, guys.
But both of them should be on. Is your ortho on?
Right now it is. I haven't really used it. But okay, so we have one line which you can click on and another line which you can also click on. So let's turn them into a polyline, meaning two lines or more joined together, right? By selecting both, you can click on one and then shift click the next one so they're both selected, or you can select them both with a square selection, just like that. And then run the command, guess what it is? Join, right? Join these two things, great. And it says over there on the top, or if you look at on your command bar, two curves joined into one open curve. Once again, pay attention to that. Open, it's open, right? If we wanted to make a flat surface off of this open curve, then Rhino will say no, because your curve is not closed to define a boundary to make a face, right? So that's another thing to keep in mind, is a curve can be open and it can be closed. Therefore, whatever you make off of it will be open or closed, okay? So always from point to curve to surface. Great. So with that said, once again, you already know that you can join objects. So let's go back to the other extruded box that doesn't have a cap. Let's leave it without the cap, okay? Select it and hit explode, enter. With the explode already entered, you have separated all the faces of this object into separate walls that you can move away or put back together if you needed to and join it again, right?
So I tried to separate mine.
Maybe because you pressed the little circle on the arrow, which I didn't tell you about, but it does an extrusion. I showed you the shortcut, which is pressing Control, but it's the same. So make sure that you click on the tip of the arrow to never be wrong. Okay, any option that you want to change, just type in options, right? And look for, okay, why do I want to change the options of the gumball? Look for gumball, right? Rhino is very straightforward when it comes to that. That's why I won't spend a lot of time going through the options because there are many. Perfect, so you've separated the faces. Same goes for this geometry where you can turn on the points. Now this is no longer a solid, right? Any of these faces, they're not solids, they're just surfaces. So they have a different language when it comes to control points. So you write points on, enter. Wait, that's wrong. Points on, I typed point on. Point on, enter, and you will see the corner points, or as many points as this surface could have, highlighted, okay? Which are eventually deformable and editable. So I've manipulated and deformed this flat surface just slightly. And here's the other thing, you never have to work with the same geometry that you have just generated. You can rebuild it right there. And that's important in Rhino for manipulating shapes. So if you have a flat-ish face and it's your facade, and you want to make it a little bit more organic, right? You're like, well, do I have to start again? How do I make something that is like that? Well, I think the easiest way to grasp that is just by looking at the points, right? Okay, so if I have 4 corner points and I'm able to move this thing with them, what if I had a point here in the middle, right? The point here in the center, the point here. Then I could move the surface in different ways, right? Then I can get organic in how I'm on, and then do more things. So let's work with that. We manipulated the surface, we deformed it from the corners. we can't really go away from like this sheet of paper, right? That is just four-sided, four corners. So grab another one of those four faces, move it to the side where you can see it clearly, okay? Just move it away enough. Practice the gumball by rotating with one of the arcs that you see here that define, if you picture a sphere, right, define the axis of rotation. I'm going to pick, for example, this axis, which rotates around the x-axis, and it puts the object flat on the Rhino grid. You can also click on the arc where you are rotating, just click once, and it'll open a little box, and you can type in the degrees. Let's say you only want to rotate it 45 degrees, 45, enter, and that'll be the rotation.
How did you arbitrarily rotate that? Whenever I click on it, and I try to rotate it.
If it doesn't allow you to rotate freely, that could be because you simply have the ortho on, okay? So it removes the freedom of rotation. It's trying to do it orthographically, like 90 degrees, 90 degrees, 90 degrees, you know? So if you turn off ortho on the bottom here, then objects become even more liberated when it comes to manipulation, because there's no snapping going on to like an orthographic projection. It's fully organic, and you're free to put it wherever you want. But if you press shift, notice how ortho gets highlighted on the bottom. So that's a shortcut. If I do shift and leave it pressed while I rotate, I will see a more a segmented rotation, right? Shift pressed and then rotate with shift, then I can go 90 degrees, 90 degrees, 90 degrees, 90 degrees, okay? So keep that in mind.
So for the points that you use them for the surfaces,
Mm-hmm.
you type points on.
Mm-hmm.
But for the objects, solid points on.
Solid point. If it's solid and closed, yes.
Okay.
Yeah, because it's a solid object, it doesn't have surface points or control points. That's the difference. Okay, so now that you've put this object flat on the ground, select it, and you see that there's one surface selected, obviously. Now find the command rebuild, enter. It'll quickly give you a preview of what it will look like with the settings that are there by default. And this is the first time you're seeing these settings, I assume. So it's important to understand. One is just U and B. Don't get confused by that. U and B is the same as X and Y, right? It's just that it's telling you it's the X and Y of the surface. So it's X and Y, but we call it U and B because, you know, for confusion and whatnot. And then degree. The degree of the surface by default was 1 because it only had corner points. So it was a less organic surface. As long as you have degree greater than 1, same goes for any line or curve, then curves become more spliny, right? Because the degree goes up and it's no longer a degree 1 curve, which is line or segmented curve, right? Those are all, anything organic is past 1. Once again, information that is important to decide what to model with, right? Depending on the geometry, you use a polyline or you use a curve that is a spline. So it will always affect how you work in Rhino. Okay, so we have the preview being shown. We haven't selected anything. Let's pick an amount of points. Right now it says I have 2 in U direction, 2 in the V direction. Let's just go 5 and 5. 5 for the first one, 5 for the second one. Observe the preview. Notice where your points will be, okay? And degree, leave it at 3 and 3. Under the options, you can choose to leave the original surface there with the original construction. I will select delete it because I don't want it, okay? You can also place this object in the current layer, okay? Which, I mean, there aren't any other layers, so, and if there are, it doesn't really matter for now. And then this retrim option is basically an option to keep the surface looking kind of the same. If it's already deformed and you're rebuilding it, the retrim will keep it looking similar, but rebuilt. So things to just keep in mind, okay? So with all that, preview is already there, hit OK. Cool. Once you hit OK, the surface is regenerated, the points go away. The command, as you know, is points on, or there's a shortcut, F10 on the keyboard. Turns on the points for the object selected. Has to be selected first. Great. Then the points show up. Now, just by nature, because you've already seen it, you can deform any point, right? And as long as you do, you have a surface that no longer behaves like the other more segmented or planar surfaces. Yet you can still manipulate the corners if you needed to, right? But now it behaves more as a fluid, malleable surface.
Can you repeat the F10?
Yeah, select the object, the surface, and hit F10.
Working with the sound, actually, it's not.
Oh, okay.
Oh, yeah, okay.
Do remember though, it's a shortcut. You can always type in points on.
Okay.
It's the shortcut for points on.
Okay.
For the points on command. Yeah. That's another thing inside of Rhino. There are commands that have shortcuts. And you can also specify your own shortcuts if you need to. Okay? Cool. So now you have an organic surface to work with, which then has the same Rhino options that other objects have. So let's go to one of the corner points, whichever one you haven't moved if they haven't been moved. Okay, click on them on one of those points. Click on the arrow that's going in the Z direction, the blue arrow. Open up a little box and specify how much you want to move it. I want to move it 10 units, 10, enter, and see what that does. Same goes for the other axis. Let's pick the x-axis, click it once, move 5 units. So if this were to be some kind of roof structure that you're designing, right, you know that you can really manipulate based on a floor plan that you sketched previously, right, wherever your roof goes, if that's where you were focusing on, right, then you have an opportunity to model freely, yet eventually move things in a specified direction if you have to. Yes, that's the other thing. So this surface is a little severe, so I'll grab this point, and I want you to do the same with the point you manipulated, and orbit around the point itself, so that you find, on the gumball, you find these planes, these little rectangles that show up as you reposition your view. They are important because it shows you what plane you're looking at. Like right here, I'm obviously looking at, if you look at the little viewport widget down here, I'm looking at XY, right? If I move that way, I'm looking at Z, Y, right? So that little plane right there is also clickable, and you're able to manipulate an object even more freely. So let's position ourselves somewhere we can see everything, and then move off of that square, not the arrows, the square. Which means you're not going in any direction other than up on the blue one or right on the red arrow or the x-axis. You won't go in any other direction because you're grabbing the plane. You're moving flat on that plane. Same goes for the other plane if you reposition your view. Okay, so pretty much north-south, right? East-west. Cool. So once it's not that crazy as far as how pulled up it was, that point, hit F11 to undo the points that are on. That's the same as points off. That would be the command, points off. Okay, very straightforward. Turn the points on, turn the points off. Now you have a surface that is still four-sided, but now it's deformed, doubly curved, right? Very organic looking, quote unquote. Select it and duplicate it, but this time instead of Control-C, Control-V, hit Alt first and leave it pressed on your keyboard. the Alt key, and then you drag and you duplicate.
You click on the-
Click Alt first on the keyboard. Once Alt is pressed and you don't let go of it, then you select, or you select the object, sorry, yes. Hit Alt and then move. Yeah, so the steps are select the object, press Alt, and drag it. That'll duplicate it. And you know what? That applies to Illustrator, Photoshop, InDesign, all the other softwares. So we have a couple options as far as giving thickness to the surface. You were asking about extruding it. Well, an extrusion could not necessarily give us what we want as far as the bottom shape of this, right? So we need to learn how to offset a surface and move it away from the original one, right? So let's pick the one you duplicated and find the command offset surface, offset SRF, offset a surface. Hit enter. Some arrows will be shown indicating the direction of that surface. There are options obviously on the command bar, which you can look at right down on your screen. First, the distance, how much you want to offset this, right? And then you have what type of corner. Does it have to be a solid or just an offset? Blah, blah, blah. Double-sided, yes, no. So let's start with the simplest part, which is the distance. Let's just offset it 1, leave it, click it, hit 1, even if it's a default. Okay, and then enter. Goes back to the menu options. Leave corner as is. Go to solid, click on it so it's no. I don't want a solid yet. Make sure it says no.
Says no.
Yeah, that solid says no. Okay, the options are still active. And then both sides also make sure it says no. Once all of that is secured, then hit enter, and you'll see the offset surface, which may or may not be a clean surface. In my case, it's not very nice because the original one was very severely deformed, right? So I see some self-intersection going on here, which is not very clean, right? I see maybe some pinching going on this top part and the inside offset surface. So that's not very clean. So those are things that we need to keep in mind when we're modeling freely. That doesn't necessarily mean that we're going to be able to make a thing that can be built. Yeah?
So how can I change the direction of that offset?
Great question. So select the object again, repeat the command offset surface, and instead of going down for distance, click distance and do -1. Enter 2 times. Oh, wait, I didn't do it. Select the object, offset surface, click on distance, type in -1, enter. Oh, it keeps saying, there you go. Maybe it was never like that. You should always be able to enter a negative value. But yeah, if you flip all, the direction will change. But honestly, you've always been able to offset either negatively or positively. Anyway, so there you go. And another thing to keep in mind, offsets that are positive going up or out versus offsets that are negative going in or down. The ones that are up are always nicer and cleaner because it's easier to move the geometry away than to squeeze it down, right? So keep that in mind as well, okay? So there you go. And this surface, as you see right away, is very different from the one that's here, and it's very different from the one that's here when it comes to the construction of it. You see more isocurves here, you see almost none here. Very clean surface as far as all the little lines crossing, and the top one has different ones too. Yet, they're all surfaces, and you can turn the points on and deform at every single point if you needed to. Yet, that's a lot of points, right? I don't want to spend all this time deforming points. So maybe I need to rebuild the surface again, which I've already learned. Hit escape so the points are not on, select the surface, rebuild the surface with rebuild, look at the total number of points I had after the offset. Automatically, it gave me 23 in U, 24 in V. Obviously, it added points on its own, but what if I needed to have less? Okay, I want only 10 in in U, and 10 in V. Leave the degree the same, leave the rest the same. It shows me where these lines are going to be now. I hit OK, and I have a rebuilt, cleaner surface that looks very similar to the one I had offset. So you can work with one geometry and manipulate it enough until you get to something that you like, right? So the next step here is, now that we've manipulated some geometry, is to draw a few curves and then bring in an object that's in that content folder that has been made somewhere else, right? We don't know where it came from. It's an object that is foreign to Rhino. We'll import it and we'll see how it looks and what we can do to it. But first of all, let's finish our understanding of the manipulation of this geometry. So now we have selected this surface that we've rebuilt, right? And right where it is, you can extract its curves, meaning its edges, right? If you needed them. And most of the time you end up needing to extract curves or extract points or use geometry to work with, right? So let's select that guy, move it away from the other offsets, okay? And find the command silhouette, S-I-L-H-O-U-E-T-T. But as soon as you start typing it in, it'll give you a shortcut. Silhouette command, hit enter once you've selected the surface, and it'll immediately delineate whatever is a silhouette according to Rhino, okay? And it makes these lines or curves that define the edges of any shape or the silhouette of it, right? It's a 3D curve. Now click away from it or unclick it, right? Go back to where it is, click on the object, the edge of the object. It'll also highlight the surface, obviously. Select curve, that's what you want, not the surface. And notice that it'll give you a curve that is right on that edge, but it's not joined to the other edges, right? So silhouette produces curves that are split into all these sides. So with shift, select the edges one by one until you complete all the curves that were loose. Once they're all selected, maybe not so much anything else that wasn't on the edge of the surface, you can leave them unselected. But as long as you have the 4 sides fully selected, leave them on and then hit join, which you've already learned. Join, enter. Now you have 4 curves that have been joined into one closed curve.
So not a curve, the part that's raised is right there, and then like a bunch of tiny.
You can ignore that one. Yeah, that we didn't really pay attention to. We just wanted the edge of the surface. Once it's joined into 4 sides, or the 4 sides are joined into one curve, you can also work with that geometry, right? Move it aside. Same rules apply. You can extrude this shape or you can deform it. Good. Yeah, we'll show a little bit more of surface creation, and then with the object that we're going to bring in, we'll create surfaces off of the object. And then we'll jump into some fun grasshopper. We haven't even finished learning Rhino yet. There's so much to learn.
Does anybody need to take a break?
That's another thing I was going to say, that it's 3:15. We could take a little break to kind of like refresh, but we can keep going also for a little bit. I say we keep going until we're just too saturated. Okay? But if you really need a break, just go ahead. Anyway, so we made the joint silhouette, right, of the object. We pull it aside from the surface. We're not paying attention to the design at all. We're just understanding the play here of geometry. So click on that curve, however deformed it is, okay? You have now another 3D object that also has control points, but that has no shading, no surface component. It's only a curve. So let's do two things. The first one is to duplicate the curve itself. So we have two to work with, okay? Hit Alt, once you select it, drag it to the side. So that's your practice as far as muscle memory. Alt, drag, equals, duplicate in all the programs of the world. Almost. Okay, so now go back to the first one before you duplicated it. And run the command patch. So patch is very handy because it'll create a patch on any closed boundary or most closed boundaries, even though they're not flat. Okay, you hit preview to see the patch, what it will look like inside that curve. Okay, different from the surface that we got the silhouette from, it no longer cares about that bump that we did on there if you did it. Now it only cares about putting a patch 3D wherever it fits this shape.
I didn't patch that.
Okay, it made it bigger?
Yeah.
Okay.
Outside.
Yeah, if it's outside, do automatic trim and hit preview.
That's already.
Okay, sometimes that's what I was saying. Sometimes the patch will draw you the patch inside the surface. Sometimes it doesn't. When it doesn't, that means your 3D curve might be a little bit too crazy that it can't figure out a nice patch other than fully around it, you know? So just keep that in mind. So if you were to manipulate your curve slightly and it were just slightly less crazy, right? Then the patch might work. However, there are still options inside the patch that you could work with. I haven't finished it. I've only started it. So I could say instead of 10 and 10 for U and V, do 5 and 5 and hit preview. That patch will be less tight. Remember, all these lines will be the control points. So we're dictating the construction of this surface. Move away from 5 and 5 to maybe 20 and 20, hit preview, and that will be a tighter patch.
So if there is like a shape that's crazy like this and you're trying to fill this, is there another way to do it if it won't fill? Like it won't fill the
Yeah. So you're saying if it has the full patch going on, right? If it's like that.
Yeah.
Okay. So here's the trick. For all of you who had the patch working nicely inside the surface, undo the automatic trim and hit preview. So it gives you the remaining of the patch. Now notice something very important. The patch is always trying to find the surface that will be best fitted inside that curve off of a what? Four-sided rectangle, right? Always, always, always. So, okay, hit okay. You made a patch that runs through that 3D curve silhouette, but is obviously going past it.
And if it goes out.
Doesn't matter. That's what we're trying to work with. It went out of the curve, right?
Yeah.
Okay, leave it like that. But now let's try this. Select the curve again. We just learned how to extrude, right? We can drag and hit control, make a surface going up, poly surface. Just like I did. And then grab the curve again, not the surface, and repeat the extrusion whichever distance, but downwards now. Control, go down. So you're in a way intersecting the object. It's just that you have two sides, one that got extruded downwards, one that got extruded upwards. So make sure that you have two. Click on the one on the bottom, extrusion-wise, and then click on the top one. So there are two of them. If you select both of them with Shift and then hit Join, you will have two surfaces or polysurfaces joined together, making a bigger polysurface that is passing through the whole object that you can now click, okay? And here we get into the more physical operations of Rhino. You've selected the object going through the surface, look for the command trim, enter. And anywhere on your 3D view, just click on whatever is outside that intersection and give it a minute. If it doesn't intersect it, in my case, it didn't, right? I can't get rid of what's outside. If you can, let me know. If it didn't work, okay, hit escape. Okay, select the surfaces that you joined. Okay, and delete it. And go back to your curve. This is perfect. These workarounds are always the real problems, you know? So select your curve by itself. Move it up without pressing Control, actually moving it away from the geometry. So anywhere past where it was, okay? Now what you do is you select the shape that you moved away from the surface. Hit the command project, enter. So you're going to project that curve onto the shape. So it's gonna ask, select something that you want to project onto. Okay, this, enter. And it'll put it back on it, right? But fully projected, so now you're sure that it's on it, right? So because you're sure, we're going to be super redundant when it comes to intersecting the surface. So move it up slightly. Again, move it away, right? And then move it downwards, hitting Control so you extrude it again, but now passing through it as a full object. Once your extrusion is done, select the extrusion, hit trim, and click on one of the outside parts of the surface. It should work. I'll repeat. Select the extrusion that is passing through, hit trim, enter, and then just click on anything that hangs outside of the extrusion. So now we really told Rhino, hey, make these two things intersect, make sure that they're intersecting by projection, and then still intersect it by moving it up and extruding it down. Now you're always sure that you're intersecting things, right? And okay, hit escape. So this is a way to make closed objects that are very complex and that you can't just hit cap, right? Because it's too complex to cap. You have to make it manually. And that's what we did. Okay, so to keep using the same object as our practice and to finish this, the trimming operations, select what you use to trim, the extrusion. And now look for split, enter. Now it's gonna ask, okay, select the object that is cutting or that you're splitting with. Okay, now I'm gonna use the surface itself that was inside, okay? Select it and then hit enter. And Rhino is telling you right there, hit enter when done, right? Okay, now click away and notice that I've split, right? The extrusion right at where the surface is intersecting. So very physical, very, very physical as far as manipulation, cutting, and getting rid of things. The line is still there. You can still work off of it if you needed to. The other stuff is there, so you've really grab your geometry, take it apart, put it back together, rebuild, reconstruct, make a cut here and there. We all have a second one that we moved up, curve. If we don't have it, find your curve that you were using initially and move it up and scale it down with the gumball. Notice how when you click on one of these handles on the gumball and you only move in that direction, you will scale it only in that direction. You might not want that. So also practice pressing shift so the scaling is proportional. And what I've done here is I'm simply scaling it inwards, making it smaller, whatever distance, so that I know it's smaller than the original curve, right? So if I move away, remember, control, right click, zoom out, and then orbit around to kind of go to like a top view. Not really on a top view, but I'm looking at it from the top. I know it's smaller than the original boundary, okay? So why not grab that, project again, enter, pick the surface again, enter. I have a smaller projection going on, select it, hit trim, click inside, and now you cut a hole.
To project like a curve into an object,
Mhm.
you must have the same edges, right? with the two.
No, you just have to be able that it can be projected on it, that it lands on it. And even if it isn't, it will still project. It just won't be a full projection. Like whatever doesn't make it won't make it.
But
So
that curve will not change, right?
no. Well, it will change. This could be a flat curve, right? And then you project it, it'll be like this, right? It'll take the form of whatever you project.
Okay.
That's really the key. So with that said, everything that you've done so far, hit escape. Okay, this is obviously a practice, right? Grab everything, and let's get into our file management here, which is, it starts inside of Rhino. Okay, first of all, we have to be able to manage what we're making. Okay, click on layer. If you don't have layers open, run layer, enter. And right under the layer tab, there's a little blank icon, blank paper icon, and hit on it. So hit it so that it creates a second layer. Then click away from it. The layer that is being used always has a little check mark. You have to double click the layer to make it active. So double click one, double click the other. That way you're used to quickly switching between layers. Very easy to do by accident, okay? Activate a layer. Let's say you're going to turn it off on the little bulb there, but you, for some reason, actually made it active. So that can happen, just be mindful, okay? Now that you have a new layer on, change the color. Click on the square with the black color in it. Choose any color that you want. I'll pick red. Now it'll show a red square. Very straightforward. Grab all the geometry. In this case that we, for some reason, want to put in that layer. We're managing our file and we want to grab all of those things that we made, put them back in a different layer. So go to the layer that you made, whether it's active or not, doesn't matter, just make sure it's highlighted. And then right click it and find change object layer, almost all the way to the bottom. Change object layer will transpose those objects into that layer, even though it's not active, and you'll see the change in the color. Sometimes you don't see the change if you're like maybe in a render view, You will notice it in the edges or the curves, but you might not notice it in the shape itself. So just remember that too. So now your objects are in a new layer, which you can hide, and the clutter is gone. Okay, hide it with the light bulb. Put a lock on it so that even if it comes on, you can't select anything. So there's no problem with you working in another layer. Okay, this is completely locked, and it's also something that you can hide. Okay, and take an opportunity right where it says layer 1 or whichever number came up right there, and once it's selected, click on it again so that it lets you rename it. Or right click it and find rename layer. Okay, same thing, name it whatever you want, in this case process. Okay, it's just process stuff, and default is still the active one, it's still the black color default, and let's just stay on the default side of it. In the next half hour, we're going to play with an imported object that we didn't make, but that, let's say, we're reverse modeling, right? We want to make it again, but in Rhino cleanly, because we care about that model, yet it came from somewhere else. Let's say a 3D scan. Someone scanned the face of someone or a head, and you're trying to make a mask for them, right? Just being general. Then you got to be able to at least use that 3D scan. So to bring something into Rhino, any geometry that is accepted in Rhino can be imported with the import command, or you can go to File and find Import. Okay. Import, enter, and find the folder that you downloaded, the 01 intent content. The file is not there, is it? Do you see a file that is an OBJ file? Probably not, huh?
No.
Okay, I'll make it available. It's not a heavy file, so let me transfer it to you guys. I skipped that one by accident. So did I delete it or what? I think it's, yeah, human head. Okay. Open, transfer. Okay, download link. Put it on the notepad here. This you don't have to unzip, just download it. Download it and leave it wherever it downloads to. Don't open it, don't double click it, it's just an object. That link that I just put there? Oh, well, I think you picked the folder where to download it, right? Or downloads. Just like start downloads. See if it's there once you download it. But yeah, just copy this. Take a minute to download it. Should finish fast enough, the download, and then you should be able to find it through the import command wherever you put it.
Can we see the link again?
Sure. Yeah, you guys tell me when you have it. We're doing great on time, by the way, and I thought I'd see a lot more frustration going on because it can be very overwhelming sometimes to pay attention to all the commands and follow through. Any comments or opinion, like something you're not liking so far?
I had a question about
What is it?
points on command.
Uh-huh.
Like when there's points on the side, is that command? Like when
The
you-
shortcut?
No, like when you edit the points.
Yeah, okay, so you have to select the object always first, right? If not, it'll ask you to select it. But the command is just points on. And if you want to get rid of them, points off. Or F10, F11 on the keyboard. F10, F11. That's only if you need to deform the points.
Alright, are you guys working at I or just do it?
Oh, it's 2 to 5.
They may want to free.
Oh, is it 2 to 3?
Yeah.
Oh, sorry. I think, yeah, it's 2 to 5.
You have to go?
If you have
Yeah,
You do?
This is-
Okay.
This is being recorded, so,
But I will maybe even more happy. Who can stay? Who will stay? You stay? You stay till 5? You tell me. I mean, we can also make it available.
Wait, I'm trying, yeah, I mean, I can stay.
Okay.
I'm trying to download it here. I don't 555.
Let me see. Fine. Okay.
Okay, all right, got it.
Cool. Once it downloads, find it in that folder. But first, go back to Rhino and hit import. Import, enter, and find the folder where you put it. humanhead.obj. If you can't see it, where you put it, make sure that we're on this option here, the file type. You have a bunch of file options that you could import, many different types like AutoCAD and SketchUp and whatnot. Let's just make sure that all of them are visible. So all supported files can be found, which means I can import that OBJ because it's in that list. Why did I put it in that folder? I think that's a mistake. Anyway, hit open and it'll ask you a question about an OBJ. OBJ stands for object. Most objects can be exported as an OBJ, but as soon as you export an OBJ, it becomes a polygon or a mesh, right? So it will always be that. Okay, so now we have our import options here. What do you want to do with this, with the OBJ groups? Turn them into object names. I don't want to do anything, so just hit nothing. I do want to import the objects, so make sure that the objects are imported. And then there are other things, blah, 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 where it says map OBJ to Rhino Z. Now, I won't lecture you on it, but Rhino is kind of like the only program 3D oriented that puts the Z-axis up. A lot of these programs have the Z-axis going in depth, right? Because that's how 3D kind of started with like camera, and in real life, this is Z, not this, right? So most meshes that come from somewhere else will be flipped as far as thinking that is Z. So Rhino, very handy, gives you an option here. Hey, whatever OBJ Z has here that I'm importing, turn it into Rhino Z, right? Because I want it facing up. And it might fail, but you hit OK, because that's like your only option. And zoom out if it's huge. Oh, it did work. It put this object facing up vertically, so it respected the rule, right? Now you have a huge human head there. And I mean huge because it's way bigger than the grid, not because it's actually huge, but now that we have an object that came into Rhino that is obviously very dense in its construction, all of these are vertices. This is a polygon mesh put together that is very heavy, but we've imported into Rhino. Let's say it was created in some other Polygon software, and now we can specify units. So let's get into units right away. Hit the command units, enter. Okay, notice that the options come up. So you can hit options and then look for units, right? But units is a shortcut. So what am I looking at? The model units, right? Not layout, only model. So model units are millimeters by default in my case. Click on that box, find inches, which is what we usually work with, or feet, right, for architecture. So let's stick to inches. Inches, select it. Leave the tolerance at what it is, whatever these values are. Okay, make sure it's still decimal under distance display, and hit OK. It'll ask, hey, you've changed the units. Do you want to scale this model by this number, which is the corresponding scale? Say yes. You could also say no, and it'll stay as big as it is, but once the units are changed, it'll be as big as it is. So it's better to just say yes, come back to it, zoom it in. Okay, click on the object, leave it selected, right click on the viewport tab, make sure you're on wireframe view so that you don't see the shading, you just see it kind of fully transparent, right? No shading going on. So this geometry, if you zoom in, it's not really usable in Rhino. Yeah, it's a nicely constructed object, but I can't do much with it. If I turn the points on, which you can do by selecting and then pressing F10, right? There are so many points, and I can't really edit this shape. and it's a big polygon mesh. It can be 3D printed for sure, but I can do surfaces off of it. Okay, so with that said, let's get into the dimensions. We changed the units. Let's hit escape so the points are off. Grab the whole object. Run the bounding box command, a bounding box. By definition, it creates a box that bounds the volume or the geometry. Hit enter twice. It'll create a box that is perfectly from edge to edge on all sides. Bounding box. With the object selected, hit enter twice, and it will give you a box that encloses the object in all directions, fully flushed. Okay, and that is helpful for what? For measuring what this is, right? So hit the command distance, enter, and distance asks for 2 points, the first point and the second point to distance, right? So first point, second point, and then the command bar tells you, hey, that's 7.245 inches, what you just measured. That distance from point to point, you can also check from bottom to top. Distance, enter, first point, second point, okay, 11.110 inches. We're measuring things off of the bounding box. Is that to scale ahead, right? Kind of like, maybe just a little bit.
I changed my units before, so it didn't scale.
Okay, no worries, perfect. So we all want to have the same object and the same size of that. So let's scale it using the bounding box, which is our guide, right? Select both the bounding box and the object by enclosing everything in a square selection. Okay, let's say that a basic human head, you know, standard would be what, a little bit more than half a foot, right? So 0.65 inches, right? So we want this. Oh, wait, we're not considering the net. This has the net, right? So let's just call it 0.85 inches, almost a foot. So think in decimals a little bit, right? So from the bottom of the neck to the top of the head, no hair, we're like almost a foot. We want that to measure that. So, okay, select everything, hit scale. There are multiple scale options, but you only want to select the one that it just says scale. Scale, enter, and it'll ask you, okay, what's your base point? I want to go from the bottom, and your scale factor or reference point would be my second point. Okay, I want to go from the bottom to the top for my scaling option, right? Now it's active until I hit enter or specify a number, right? I haven't specified the final scale, but I know what I wanted, right? I said 0.85, so 0.85. Sorry, yes. Yes, sorry, I was thinking in feet. So it would be 8 inches, right? So let's just call it, no, 0.85 of a foot would be, yeah, I guess. So 8.5, so 8.5, we're in inches, right? So 8.5, enter, and it'll change to that size as a whole, right? Don't get confused with scale 1D, because if you don't do this one, if you pick scale 1D and you were scaling from here to here, then the scale would be like this. 1D stands for one direction. So, not the band, or whatever they are. Okay, cool. So, I deleted the bounding box because I've already scaled it. That's all I wanted it for. It's a reference, right? Just a box. Okay, goodbye box. And now grab the object and make sure that we put it in a new layer. We know how to do that. Go to where default is, hit the new layer button, type in imported model, enter. Change the color to something else on the square. I'll choose brown. And now select the object again, right click the new layer that you made, and change the object layer so that it's in the new layer. Now, how come the objects, if you turn on the process layer, the objects that you made before and then you put in a layer with a different color, how come those are red and this guy is not brown if I chose brown or green or whatever, right? That's because it came from somewhere else and it has some other setting. As yours changed? Great. Okay, mine didn't. Are you on wireframe? Ghosted, or what are you on? What? Let me see. Maybe I didn't change it.
Just brown. Oh, you're brown. Reddish. Oh, that's weird. Yeah, mine changed too.
Okay, well, if in case it didn't change, next to layers, you can practice this. If you don't see properties, click on the gear icon, find properties, so it's on there. Properties shows you the object display properties. Once it's selected, it'll show it to you. If not, then nothing will be shown as far as an object. So click on the object, and then you see display color. In my case, it says black, so that's why it's been shown as black. But if I were to click on this button here and go by layer, then it'll be by whatever color is on that layer.
Once you click properties,
You have to select the object to see the object properties, right? Cool. So now it's brown. Okay, so my object is on the imported layer and I haven't locked it or anything, but it's there. And my active layer, it's still the default one. Cool. So I'm going to, now that I've scaled the model, to try to generate part of the below the eye here. So this surface, now right click the perspective viewport tab and choose rendered. Sorry, Arctic. Rendered might show the object fully black because of the material issues from where it came from. Okay, but Arctic usually puts in a mask on it that shows everything kind of frosty. So now you see that it's a nice object. I mean, it's nicely modeled, right? It's not an ugly model. And they modeled it in a polygonal-based software to make all these shapes, sculpt it out and everything. But we need to make a technical surface inside a Rhino that maybe defines a patch right here, because that's like a product, right? A wearable product that we're working with. So let's use what we learned, that we can make something and intersect and grab geometry off of something else, right? To maybe grab this piece right here and just make a surface that follows that sheet, right? As in, you may be working with a terrain, right? And you're trying to go off of a terrain to make an extrusion later and model off of that. The only reason I'm not working with a topography is because we assumed that we're going to be general designers here. So we're working with something as basic as a human shape, right? But it applies the same. So given you have this object, now find what we've already done, the rectangle command, rectangle enter, okay? Draw a rectangle, just as long as it's bigger than the head on the floor. There you go.
So what view are you in? My grid.
Perspective view, look at this. Right click the perspective viewport and hit Arctic.
Well, you're talking about the grid that is missing. Like,
Are you on perspective view? Okay. Are you able to come back to it by double clicking the viewport tab and finding perspective?
Yeah.
Okay. But you don't find your objects?
No, I don't see the grid. I think
Oh, okay. If the grid is not showing, go to display. Remember display next to layers? And go all the way to the bottom and tell it to show the grid. Or remember the command grid H, grid enter, H enter. Cool. But yeah, we don't need the grid. But yeah, it's there. So you have that, and you have a rectangle that is way bigger than the head. And if you picture what we're doing, if you remember the little PDF image, right? We're going to intersect the object, not to cut it like I did in that image, but to generate an intersection by itself, meaning a curve. Okay, so now that that's set, let's grab this rectangle and learn how to turn a flat curve into a surface with the planar surface command. So you're making a surface that is planar, meaning flat. Planar SRF command. Enter. It'll turn any curve that is closed and flat into a surface, right? So we're going to use this rectangle to intersect this shape in a little bit, but just as a proof of concept, bless you, as a proof of concept, draw a new curve. And by curve, I mean an actual curve. So type in curve, enter, and place some points organically as if you were just drawing some kind of splash until you find the last point so that it kind of closes itself. Come back to the first point. The command is curve, just curve. And start placing points that define your splash, right? And then get to the starting point at the end and just close your curve. Once you do, apply your command, planar surface. That way, proof of concept, any surface can be turned into, any curve can be turned into. So on and so forth, you already know, you can grab that, you can extrude it, you can do the same to everything, right? Same rules apply. So yeah, now we went over that. Go back to the rectangle. You can get rid of the curve around it, leave only the surface. And let's rotate it vertically with one of the, look how I am repositioning my view. So I find that arc. I'm going to rotate it with shift so it's straight.
How did you just straight on feet?
Oh, I just moved around like that. It's kind of like eyeballing. I'm not really straight, right? Like straight looking at it orthographically. But I don't need to. But I know that the rotation is fully flat because I press shift. That you know. So let's just turn it into a vertical plane, no longer a surface on the floor. Okay? And place yourself in a view where you're able to see it passing through the object like this. And let's just put it right in the middle of one of the two eyes. Probably the red eye, the right eye for everyone to be on the same place. Okay? And I'm going to orbit around it and see, check that, yeah, it's passing right through there. And don't worry, Grasshopper will be more of like, here's a file, it's already done for you, right? Let's move it around so we can kind of like discover what it is. We're not putting together a Grasshopper from scratch because then we'll be crazy. We'll go crazy.
Did you delete this?
The other shape, I got rid of it. You can just put it aside or whatever. Yeah, go to ghosted. It doesn't matter. It's just, it looks nicer. But yeah, memory is important on the computer.
Yeah.
These computers are old.
Like delayed slightly.
I believe these computers are from, I don't know.
No, yeah, they're old.
Yeah, they're from like before 2015, I think. And that's not that long ago, but consider the differences. They probably have what, 8 gigabytes of RAM? 12 at the most? Anyway, so now we're on the ghosted view, we're intersecting the object, okay? Now to intersect anything in Rhino, you hit intersect, that's the command, right? But you need to find objects. So we're going to show you what that error is. But, so let's do it, let's just type in intersect. Intersect, then Rhino is going to ask for objects to intersect. Okay, I want to intersect this human head, click it, or the surface, sorry, whichever one first. And then with shift, look how I can't click on the mesh. Can you?
No, they didn't.
Right, you can only click the surface, right? Because Rhino is trying to intersect things, but Rhino does the following thing. It's like, okay, I'm gonna intersect surfaces with surfaces or solids with solids, and it all works nicely. But when you have a mesh being from not native in Rhino, you're going to have to intersect meshes, which is just another intersection. But often,
Explain what a mesh is.
sure, I will in a bit. So we have to turn either the head into a Rhino surface, which is really hard because it's really complicated, or we turn this very basic square into a mesh, right? Probably easier to do that. So to convert anything to a mesh, you hit mesh, enter. You're meshing an object. So hit escape first if the command is active. Escape, 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 command should be clear. Select the surface that you are meshing, hit mesh, enter. Now it'll give you a little polygon mesh options bar. It's like less polygons or more polygons. I don't know what that means unless I hit preview. I still don't see anything. It just, I see the same thing. So it doesn't matter if I have more polygons or fewer polygons. What that means is that it's asking for a subdivision of this surface. So if you have any geometry that you're turning into a mesh, it'll subdivide it, just like when you rebuild, right? Like this, into many, many squares or faces of the mesh. And each point being a vertex, 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 every single point, right? Very different from points and faces in Rhino geometry. A mesh has faces, edges, and vertices. Just two different kinds of modeling, right? Let's say you're in the character design industry, you're working with meshes, making animations and stuff. But here we're working with technical surfaces. And okay, so, but what's going on here with the subdivision is that this is a very simple surface. So Rhino doesn't really care. It's only if you choose fewer polygons or more polygons, it'll still just do like, okay, one edge here, one edge here, one edge here, vertex 1, vertex 2, 3, 4, that's a mesh. And Rhino doesn't care. Doesn't matter. We just need one mesh to intersect another mesh with, okay? So let me clear these drawings. So yeah, leave it wherever it is, hit OK. Now that is a mesh. It looks the same, but it's a mesh, and you can click through and grab either the surface or the mesh, enter, hit OK. Okay, grab the surface, make sure that Rhino, the command bar says one surface added to selection, not one mesh. You want to select the surface. Delete it. The other mesh, the mesh is still there. I actually made it twice. I'm going to delete the other one. Okay. So you have a mesh passing through the other mesh. Now you can grab both, hit mesh intersect, and grab an intersection right where that is happening. It might be dirty, which it is in my case. Doesn't matter. I'm just trying to intersect. Okay, so where that plane is crossing that geometry, there is a curve generated. Did you guys have the same issue like I did? This kind of stuff?
Yes.
Okay, don't worry about it. That can happen, and that's because we don't have control of the other object we're intersecting. It's as is. Okay, great. So let's grab the surface that intersects everything. Just pull it aside because we don't need it yet. Okay. Hit wireframe view. Right-click the viewport tab. Hit wireframe so that you can see through the object. Go back to layer. Hide the object, the imported model layer. Now you only see the curve and that cutting plane over there, the intersecting plane. That we only did so that we're able to zoom in and identify what's going on. Click on the intersection itself, and you'll see that it selects everything. It's one joint curve of intersection. No worries, man. It will be, thank you. It'll be available.
We'll send out the video. So you can see
Yeah. All right, so this curve right here is made of all these other curves, and that's how it came in the intersection. So select it and explode it so we can clean it up, okay? Explode the CAD or the curve that was produced from the intersection. Now click away from it and you'll notice right away that it's broken into many, many little curves that might be very hard to work with. But we're gonna at least get rid of what we don't need, this long curve over here, in my case, this other long line over here. Once you get rid of the long lines that are really the messed up ones, you can just grab all these lines like this in a square selection, hit join, enter, and let's see what Rhino says. In my case, it says it joined 325 split curves into 8 open curves. Okay, that means that I have 1 full curve here, number 2 right here. Okay, it's possibly these few little ones that are just very tiny and that I don't really need, that I know I can delete. Now I can just grab my big curves and zoom into the area where there might not be fully joining. Like in my case here, it's right around where the eyelid is, or the on top of the eyebrow, that it doesn't fully join. But zoom into that broken area, okay? Just like I have right here. If you find a spot similar to it, hit line enter, and just draw a simple line from there to there. Actually make sure that it's fully snapping from one point to the other, okay? Now you can grab the whole thing again with that little line you made and hit join. And if it still doesn't join into one close curve, which it did right here, it's 1, it's probably telling me that there are some minor ones still selected somewhere, 30 ones. So by clicking and selecting, you realize, okay, is this showing me a full selection of the curve? Yes, okay, I got my full curve. Anything else doesn't matter.
Mine is still 2.
I did say, though, that we're going to generate a small patch, right? So I just wanted to first clear that part that we're able to intersect fully. But now we're going to intersect a tiny fragment. So it's not so hard to clean up and work with, right? So we start with the difficult part, and then let's go back to ghosted view. Okay, we made that curve, we cleaned it up. Okay, let's make sure that what's clean here, put it on the other layer, the process layer, right click process, even if it's hidden, change object layer. If it's already hidden, the layer, it'll hide immediately because I moved it to the hidden layer. So now I have my human head here again model and my plane. I'm going to scale this plane with one of the scale handles, pressing shift so it's proportional, something tiny, and move it to where the eye is, okay? Doing everything in 3D, not relying on any other view. Rotate it flat. Reposition yourself in case you go past the eye, like really get it to where it needs to be. In all the views, you can move. If you are, yeah?
So I'm not going to scale mine.
Okay, I'll show you again. Whenever you have an object selected, make sure that you are able to see the handles of the gumball. By handles, I mean the little square controllers coming out of the arrows. Okay, click on it, pressing shift so that, and leave it pressed and dragging so that you scale inwards or outwards. And practice that for like a second. Right? Okay, our shortcut to put that intersecting plane near the eye is to use the move command. So we've been relying on the gumball to move things everywhere, right? But if we want to be specific, we need to be able to move from one point to any other point, very specifically. So let's select the little plane that we scale down to about the size of the ear or whatever, and hit move command, move enter. It'll ask you, okay, what point do you want to move from? I'll pick any of the corners here of the box, of the little surface, of the mesh, sorry. This is a tiny mesh. If I can't click on the corners, Smart Track is not working. Remember, the points on a mesh are called vertices. So I need to make sure that vertex is on down here. On the bottom, turn on vertex. That way you can snap into the corner of a mesh or the vertex of a mesh, click on the point you want to move from, zoom out a little bit, scroll out, and then zoom into the eye. So somewhere around the eyelid, you should be able to identify all these little points of the mesh, okay? To place that plane anywhere on the eyelid, really, kind of like close to the center, okay? And then zoom out. You might, by accident, place it behind the neck or something because it's clicking on points somewhere else. Just make sure that you orient yourself on the view well enough so that you see it right on there where you want to place it, okay? Don't forget that Rhino is trying to attach to all the vertices, not just one, right? Okay, so I put it right there. It's passing right on on top of the eyebrow. So let's make this shape horizontal by rotating it with Shift. There you go. Let's move it down so it's under the eye. And then push it in so it actually goes into the face. Like this. Not fully, just enough. You can kind of already picture the area that I'm intersecting, right? Okay. Now you have one mesh and another mesh. Select them both. Hit Mesh Intersect. Enter. There's one intersection found. If it says I found one intersection, that means it's one joint curve. So don't worry about it. If it said I found 3, but you only see one drawn, then it might mean that it's broken into 3 curves, right? So you can be fully sure, that it's only one curve. Cool. I made one intersection off of the mesh surface, or geometry, right under the eye. Cool. I can click away from that and reselect the intersecting mesh, bring it down, maybe 1 inch. So right click the arrow, the blue arrow, and hit -1, -1, enter. It should move it 1 inch down, right? There you go. And now that you have this surface moved down and still selected, also select the mesh. Do it again, Mesh Intersect. I have a second intersection going on. 1 and 2. Found one intersection, great. Only joint curves. Okay, so if you picture what we're doing, and is generating a total of 4 because we want to have our first edge, our second edge right here. We want to generate 2 more intersections that guarantee 4 sides, as you see in this little sketch. Because once you have 4 sides, you're able to make either a patch or a network surface or any other geometry that can really be used in Rhino. Once you have 4 sides to construct with, then you're good, okay? So picture this same plane right here that we've been using to intersect. Now flip it up so it's like this, right? And let's get 2 intersections going in the vertical direction. I trust that we can do that on our own, but I'll still do it so we see it. Rotating up with Shift. Reposition, push it in towards the face, move it up so it crosses the other 2 intersections. Move it aside again. Mesh Intersect. Nice. And Mesh Intersect. Cool. I've generated 4 intersections. All of them meet at a point somewhere, at least in 4. locations, right? It's 4 locations. So I am happy about it. I am going to grab every single curve. So that it doesn't interfere with me clicking on it because the mesh is there, I'm also going to put a lock on the imported layer, which is where the mesh is. That way I can't click on the face. I just grab one curve, shift the other one, shift the other one, shift the fourth one, sorry. So I grabbed the 4 curves because I know it's 4 of them, and because I know they're all meeting at a point, I can run the command network surface, network SRF, enter, and it'll give you an option. And it'll identify the 4 sides if there are 4 sides, always, right? So side A, B, C, D, and you have options to go off of. The first option being the tolerance and the interior curves. Those we can leave as they are. We need to go in depth with those. It simply means how tight and really true to the intersection you want it. So 0.001 is like as tight as it can be, right? So then you have matching your edge, kind of like a second option there. You want it loose, or do you want it right on the precision? Okay, you can choose whichever, but try to stick to the 4 points being the same edge condition. And then notice how that curve is really dense as far as its ISO curves, all of their control points, because it's trying to stay as true as possible to the shape we're copying, right? But it's still very dense. So let's choose a different tolerance level. Now we do. Instead of 0.001, choose 0.05. And then click on the next. If it doesn't show you a preview, it doesn't matter. Just hit OK and see what it does. Okay, it creates a patch. 0.05 is still very small. So grab the same curves, leave that patch there with Shift. Duplicate them by Alt dragging them. Put them to the side of the object. Same patch, but now only the curves out there. Practice what you already know. Select the 4 curves, hit trim, enter. And you can zoom into all the areas where they're passing through each other. I'm going to change the background really fast so you see the contrast. There. So with trim going on and all of them selected at the same time, you can click on everything that's hanging out of the corners and end up with your nice defined patch right there. And then hit escape. So you've trimmed the excess. I'm going to go back to white background. And I have my 4 curves there. Grab them all again. We know they're 4. We just trimmed them a bit. Network surface, enter. I see the density of it again. Instead of 0.01, let's just go to 1. Okay? And for interior curves, 1 also. Okay? And then hit OK. If that still doesn't change the density, that's because, very easy, the curves are very dense. You see many control points as soon as you click the curve, right? So last practice for our rebuilding is you can also rebuild curves, not only surfaces. So grab them, hit rebuild, enter, and pretty much we can specify how many points we want per curve. Let's say I want the 4 curves to have 10 points, and the degree should be 3. Great. And delete the input, please. I don't want the input curve.
What about create new object in curve?
Yeah. And preserve and tangent directions too, so that the corners are maintained, and hit OK. Okay, once you click on the edges, you'll see way less points, but very similar shape still, right? That should give us a less dense network surface. So select them all again, network surface again, see that? Huge difference. More workable surface, right? Because the points are now very little points. Select the surface, turn the points on, and it'll have a nice point count that is workable and not as crazy as this guy, because if I turn the points on, that one's too many. I can't work with that. I can't really edit it into something, but this is a clean, nice shape that I can work with. And if I wanted to, I could now generate the whole retopology of the shape, right? That's an example of how to reverse model off of a incoming mesh from somewhere else. Like I said, it could be a mesh of a terrain, and you're trying to define a surface for your site, for your extrusion, for your depression, whatever it is. So now you know how to intersect objects. So we know the layer with the head is locked, so we can't select it. So let's just grab everything we drew. Okay, go back to layers, right-click process, put it in there, change object layer, make it hide. Okay, and also hide the head, import it, layer, and leave Rhino blank like this.
What did you do with the?
I grab all of those and put them in the process layer. Right-click, change object layer. Grab all of those and do that. Right-click the process layer. Okay. And also hide, lets you hide the head and leave Rhino blank. So only the default layer is turned on, but there's nothing in it. And we have, well, basically a blank Rhino because everything is hidden. And as much as we can jump into so many other options to create actual, like, let's make that actual building right now, right? We could. But let's get into the basics of Grasshopper. So we have that in our heads. And Grasshopper now in this version of Rhino is fully integrated. So now you can run the command Grasshopper and it's inside of Rhino. What it means is that before, and not that you have to care,
So
they run separately.
we took the icon words. How do you get back?
Type it in.
Yeah. Oh yeah, by the way, just type in. Most of the things that, actually, yeah, all of the things, you just write them. And in fact, it's the best practice because in the past we didn't have Grasshopper. So everyone learned Rhino in different ways. Like, oh yeah, I like it like this, or I like it with commands. But then Grasshopper happened, and Grasshopper also has all the options with buttons, but it became a lot easier to just type in things and move fast, right? So then, at least in the method I've chosen since I started teaching, was just type, and it'll eventually be the fastest. Okay, so there is a file that is in the folder that you downloaded. So go to File in Grasshopper. Notice that Grasshopper is just a window that opens up as a plugin. You can close it, and it won't go away. You can always type in Grasshopper again. It'll come back up. Close it, come back up. Grasshopper. It doesn't really close until you close right. It'll be forever there once you open. Grasshopper's open. Go to File, go to Open Document, and find the one I sent you that says, I think it'll only identify one Grasshopper file anyway. That's called intent01_edge_detection.ghx. Oh, you didn't download it? Okay. You don't have it?
I downloaded it already. Just resend the link.
I'll upload it again. I don't have the link anymore. Yeah. No worries.
You may want to set up your Grasshopper on one side or tree
Right.
on the other side so you can see the full.
Both things at once. Yeah, it's always better though. If you're going to use Grasshopper, just have two screens. Always, always. It'll be the best. So upload it again, right? Okay. Actually, I'll only upload that guy. It's so fast. Transfer. Shouldn't even take a minute. Okay, there. Copy the link. Ooh. That's where you go to download it. I guess you're going to end up needing the other image that's also in the folder. I guess I should have uploaded the folder again, not the Grasshopper. Doesn't matter. We'll be fine. Just confirm with me once you have it downloaded. The file that you download though, you also don't click it, don't double click it or anything. It's just a file that will open in Grasshopper. Were you able to download it?
Mm-hmm.
Perfect. So now in Grasshopper, hit open, find the file, edge detection, open, and wait for it to pop up.
Open.
File, open, and find the one.
Edge detection.
Oh, no, sorry. Okay, so minimize Grasshopper for now. Zoom out here, see what's going on. Something's going on, right? Can't really click on it, just a preview. Grasshopper is always showing a preview. Okay, so whatever's in there, I can't select it. Okay, so that means I have to go back to Grasshopper. So what Selena was saying is maybe snap it to the side and snap Rhino to the other side so you can see both, or have two screens. And let's see what's going on here. So it's a very short code. If you zoom out with the same commands as Rhino, scroll out, you can navigate with the right click, the same thing, just no 3D. But see how short the algorithm is, right? It's like a very short operation. And it's basically doing something that we're previewing here and that we can't touch yet, but we know it's here somehow, right? So with that said, let's investigate what's going on here. But first, really quickly go over what I told you. The navigation is the same as far as zooming in and out and moving around. All these options are basically a bunch of the Rhino operations that you have to make geometry, but you also have a lot of analysis tools. So very, very quick intro when it comes to an analysis is, let's say I have a curve drawn like this, right? An analysis of a curve would allow me to find a point on the curve anywhere I want, right? Like at this value or this value or this value, but I can always tell Grasshopper, find it, find it, find it. I can move a slider up and down the curve and find the point, whereas Rhino can't, right? So Grasshopper, what it does is it allows you to do everything that you can do in Rhino, but many more times in one time. So let's say you want to move a point, well, you can move all the points in one go, right? So that's where you start getting into the complexity of it, but also the utility of it, right? It's very useful once you grasp it. So, but obviously we're going to start with, something simple and nicely. And like I said, this is a short algorithm compared to how ugly it can get. So let's see what this is doing. So zoom in to the first of the components here and read what it says. It says rectangle, okay? A rectangle is getting created. If you click on it, it highlights it. No click, no highlight, click, highlight, okay? As simple as that. If you wanna not show it, as in hide it, then select the object, right click it, find the preview option and unpreview it. You don't see that rectangle anymore. Right click it, select preview again. Okay, now the difference as far as the shortcut would be Control Q, Control Q, Control Q on the keyboard, Control Q would do the same as show, not show. Okay, and I will also point you to the websites for the commands. Like you'll know there's a Rhino command, Grasshopper commands, everything. Okay, so basically the algorithm is looking for instructions, right? Okay, define me a rectangle. First, P, where do you want the rectangle? What is the base plane? Okay, by default, it says world XY. Where is the base of the rectangle? World XY, right? Cool. I know that Rhino is doing that. I could choose some other world, but it's by default, it's choosing that. Perfect. Now, X is dimensions of the rectangle in the X direction, dimensions in the Y direction, right? If you hover over the input, it says 0 to 100. Over the input of the Y, 0 to 100, meaning that it's going from 0 to 100 and 0 to 100, right? If I wanted to, I could tell it go from negative 100 all the way to 100, make it a bigger rectangle. So that's just coordinates and size. The R is the fillet radius. So if we wanted to soften these corners into rounded corners, we could introduce a number, but we're going to leave it as it is. Cool. So what is happening here is that this rectangle is being set up so that it turns into a mesh. We recently changed a surface into a mesh. They're doing something similar here where they have a mesh, and this mesh is being created off of that rectangle. Okay? These values are simply asking for how many faces in one direction and what are the faces in the other direction.
You want to see
So remember, Control Q, that lets you see the things. So now you can see the shading of the mesh being created, which you can turn off. Okay? Now, mcomp, another command here, is decomposing that mesh, meaning that it's exploding. Okay? So if you preview it and you zoom into the mesh more and more, you'll start seeing all the points. It's being exploded into all its points and faces and whatnot. Okay? So I'm just telling you this so that you know that there's a set of instructions going on. Start with this rectangle, turn it into a mesh, explode the mesh, right? That's all. If you disconnect some of the wires, the instruction is long, but you have to reconnect. So that's pretty much it. It's just like modeling, but you're doing it off of a code, right? Instead of I draw it, I extrude, I just program it, which means it's never in Rhino. It's not there, it's previewed until I say, okay, now put it in Rhino with an option that is called bake. I'll bake it into Rhino, but not yet, okay? So that thing is exploding the mesh. Why is it doing it? That's so that it grabs all the points that it has. How many points it has? Well, the mesh that is getting created here has 220 points in one direction, W, and 220 points in the other direction, which is H. Same thing, X, Y, but for a mesh now. Cool. So deconstructed, it explodes the mesh, and then it's using a random image from online there, okay? Some image with a shade, and the person is trying to grab all the points of the mesh, and it's using this image sampler option that comes in Grasshopper. And if you orbit around the object in Rhino, the next command that you see here is move. So if you just see what's going on, from the mesh getting exploded into the move command, as it passes through the image, it moves the points up. All the points. Based off the image though. So what it's doing, you don't really see the calculation here, but just take a minute to see what the image is doing. It has a brighter side and a darker side, right? So as far as pixels, the ones on the darker side are going up higher, right? And the ones on the bright side are staying close to the ground. So basically, without getting too much into knowing what this is, you're understanding that you can grab an image, you can grab points, you can affect the points with the image, and then you have a different way of creating a model that isn't just based off of geometry itself, like in a curve and a rectangle. Again, this could serve to create a digital terrain, right? Or some form of shape based on patterns, and we will show you an example of that. So once you have this, you can notice all the points that are getting moved. Now, these points are later turning into a new mesh. So find the next component, turn it on with Control Q. See how there's like a surface highlighted right under the points. That means that a new mesh is getting made off of the old mesh, now with all these points moved up. So now you can hide these points, Control Q, only look at the mesh. Okay, you see what happened. They were all flat, and based off the brightness of the pixels, it moved them up and down, right? Just in a rule. What rule? Well, I think he put a number here on he's moving them up in the Z direction, right? This is the Z option. And if you hover over the little asterisk that is there, I think he said, move everything times 10. So again, don't be overwhelmed by that. Just understand that it's a code. And now the new mesh is made off of the image. Once again, it corresponds, okay? And then all these other little curves that you see, all these red marks, are an intersection of the mesh itself and a plane passing through. And I'll show you what that is. So zoom in a little bit and put your view in kind of flat like this in a perspective, so you see the whole thing. And then find this sec component, the last one is called sec, which is a intersection or a section between a mesh M, the M, and a plane, okay? What intersection is it making? Everything that you see in green right now, or what is being drawn in the sec command, is an intersection, okay? And the intersection is basically happening this way. So look at the command that intersects. It says, I'm looking for a mesh to intersect and a plane to intersect it with. So in this case, without showing you the other parameters, you can see the following. There is a mesh and there is some plane passing through, right? Creating that cutout. Kind of random, but that's where the plane is. That plane being here, moving up and down, okay? So now that you know that, there's a plane cutting my object, intersecting it. That's all I need to know right now. Cool. Okay, so let's see where that plane that is making the section, we'll see where that comes from. Okay, that comes from a move command. Okay, move, I know it's just moving. So let's see what move asks for. G asks for a geometry to move, cool. And T asks for a translation vector, or where do you want to move it, on which direction, right? Cool. So basically, what this person did is he grabbed an XY plane, which is the same as a Rhino plane right there, okay? And he put it on the move option, which is the same as typing in move in Rhino and selecting it, right? And he said, move it up in the Z direction, okay? This command here is actually not needed. He didn't need to do that. There you go, okay? So ignore that. He's just saying move 4.8 in Z up. Okay, that's the move. That's where the plane is getting moved. You see it there. It started here. It moved 10 times up. Cool. Original plane moved, not 10 times, 4.8. And you can see if I move it down, the plane is moving down, right? Move down, move down, move down, move down, move up, move up, move up, and see what's going on in the intersection in the background. I'll highlight the intersection again. I'll move the plane freely, and I see that it intersects where the plane is, okay? That, in a way, you know, if you had the mesh head that we were working with, you can move a plane across it and find your curve immediately without you mesh intersect, right? You can just find it, find it, find it. That's the difference. So keep that in mind as far as what we're learning in the process. So that's what this little script is doing. Once you've done it, there's really nothing more to it unless you keep building off of it, right? Right now, this person only wanted to generate curves off of that. Cool. That means that it's done. Right-click the last of the outputs and find bake. Once you find bake, it'll ask you, okay, where do you want this? In the default, in the process, or the imported, or whichever layers you have on. So just find default. Don't group it. It says, do you want to group? Yes or no? Just say okay. Cool, so now your geometry has been baked. That means that I can unclick in Grasshopper. Nothing is selected. Now I see it in black in Rhino. The geometry is in there now. I've made it in my Grasshopper oven, and then I baked it into Rhino, right? That's basically the relationship. Cool, so we don't need to learn Grasshopper right now. We'll get into it, but we need to know it's a tool that is sitting there in Rhino all the time that we can access and actually speed through everything and not even model. But that's as we get into it, right? And then you practice more and more and more. Then you can draw a point parametrically in Grasshopper, and then off of that point make a line, and off of that line make a surface, right? And you construct, never touching Rhino actually. So that is the difference.
Then be able to change it later.
Right.
without having to manually draw it, you know what I mean?
Right, because now we baked our option, right? And it's like, okay, here it is. But let's say you're talking to the client or your instructor and you're working on your designs. You know what? I don't like that intersection or it's not working right now. Okay, cool. I'll delete it. I still see what it was, but what would maybe 3 inches up work? Yeah, okay, I'll make that one. So there's now a range of options. And that's really the value of it. This is very abstract, obviously, but it could be applied very, very specifically. Cool. So the only edit that we will make, the real edit to this script, would be to change the image. Choose a different thing, right? So let's not get rid of the one that's there because I think that image is already saved in there. Let's just do what we did in Rhino before. Drag it, then hit Alt, and duplicate that. In Grasshopper, it's a little inverted. You drag and then hit Alt instead of Alt and then drag. Drag it slowly and then hit Alt, and it'll be copied with every single cable coming into it will be duplicated as well. Okay. Now, because they're the same image, if I replace this cable, by just connecting the other one like that, pull it out of the little half circle there, and you see that you can replace one cable with another. Okay. Now also right click where that cable went to, hit disconnect image sampler, disconnect the image sampler. Now there's nothing as far as an image going into the Z. Now I don't see the result I had before because I've undone part of the algorithm, right? What is it? Oh, you connected it wrong? Control Z. Same applies as in Rhino. Control Z, you can undo.
Make sure you're doing Grasshopper.
Yeah. Always click the Grasshopper canvas just in case you've gotten out of it by accident. So now that we've duplicated the image and it's disconnected from everything, let's replace it. Double click the image sampler.
Exits. And it might be because what you're previewing has a lot, you probably change another slider.
Oh yeah, that's right. You connected it there, and you have 2 going on. So this shouldn't have any. You just confuse one Z. So this. This is how you have it. So there you go. And I told you guys to disconnect this one. So wherever a cable is going into, you right click that input, disconnect, connect whatever's coming into it. So now nothing is connected to that, and that we should really mess with. So I think you just mistaken these, which is normal. Believe me, man, once you have more than 2 cables going on crossing with each other, you have lost it. All right, cool. So we made a new image sampler. Double click it. So it opens up the options. Now we'll see the image that is stored in there. It actually had color in it, but I chose, look at that button. Color brightness was my guide for this. I was trying to go off of bright and dark pixels to put the points on. I'll leave it as is. Same thing, not messing with it yet. But file path, I want to find a new image, not that one. So click on it and go to the folder where we downloaded our stuff.
Did we download that image?
Oh, you don't have it. It's in the same folder. Let me put it on that folder for you. I mean on the WeTransfer. What happened with you, man? That was the first instruction. No problem, you've done great. So, ASU, grab that image. Is a water symbol here. Sorry, the man in the maze, not the water symbol. I think I called it water, didn't I? I just called everything water. All right, transfer. It'll take a second. Copy link. There, that's the one.
that a 0 or a
That is a what? Oh, that's a 0 for sure. Got it? It's better when we have like a Facebook group for the workshop, and I just paste the link that you just click it. You don't have to copy off the projector. It's kind of awkward. It could work. Just have to put everyone in the group, and if you're not friends with them, you can't really add them to the group. It's like, oh, it's so annoying. Now you have it. Okay, now in the Grasshopper image sampler, click the file path dots there. Find the man in the maze symbol. Oh no, I didn't call it water. Nice. I was working with some of the water symbols earlier, that's why I thought I had. Okay, click open. You've put it on there. Now it's showing that it's in the image sampler. Hit OK. Now it's in there. And now when you scale the image sampler, if you do, it doesn't really mean you're scaling the geometry. Keep that in mind also. It's just you're scaling the parameter, which doesn't do anything other than that. And now that you have nothing going on to Z, plug that in there and see what happens. So something happened. I can click on the mesh that is getting created. Before I do the section, I don't care about the section right now, getting cut. Let's grab the mesh itself, okay? And I'm going to bake it into Rhino. The shortcut for baking, instead of right-clicking and hitting bake, is insert on the keyboard. Hit insert, and it'll get put into Rhino. If there's no insert, then yeah, use bake. Sure.
So just do the bake then?
Yeah. You bake what's a result of this one, the mesh getting made, not the section, the deformed mesh, before you cut a section through it. Then once you bake it, you can put it on the Arctic view and observe that geometry as something that is actually affected, deformed by what appear to be the black and white pixels, obviously, of that image, right? Very, very straightforward. Yeah. Grasshopper?
Yeah.
Yeah. Oh, no problem. There you go.
So my settings are the same, but when I imported the image, it didn't change.
Oh, I did, but it's the value of your Z unit. So if you put it on the same one as mine, 32, just double click it. You have to do it more. So let me actually show that step. Okay, everyone, if you have a different result from mine, that's because your numbers are different from mine, right? So let's check that we have the same numbers. So first, the rectangle is divided 100 times X and Y. Then the slider for the mesh plane, we haven't played with it, leave it at 220. Everything else is the same. This number right here, 3.2, is what you should also have the same as me. Yeah, just double click the slider like this and type in 3.2, enter. It'll make that sound. And now you should be able to have the same geometry that I have because we have the same file. And click on mesh, the one that's getting made, and insert to bake it. Oh, it's this value. Okay, so check that out. So double click the image sampler. I think you moved it by accident. And the value you should have right now is 0 to 100. 0 to 100, it's spelled actually how it is. 0, then capital T, then O, and then 100. If it's already like that, then don't move it.
Okay.
That should give you the exact same result I have, which gives you that mesh that you can insert once again, and it's right there as a fully deformed mesh based on an image. Believe me, this is not easy manually at all. So having a tool that does it for you in case this is what you were attempting is great. Obviously, this isn't the cleanest. Once you zoom in and you see how jagged the mesh can get, that's usually what happens, but it's a huge start, right? So now let's go back to the Grasshopper script or the algorithm right here, and let's change one of the values. In this case, for the image sampler, double click it, and right where I said 0 to 100, let's only do 50. 0 to 50, change the 100 to 50. 50 on the 100, and 0 to 50 on the other one. And then hit OK, and see the result. Okay, so now you've affected less of the mesh with the image, or you've decreased the extent of the image affectation. And remember, very simply, numerically speaking, okay, we did a rectangle that goes from 0 to 100, right? We were saying, hey, image, go from 0 to 100 in the image sampler. Now we told it, go from 0 to where? 50, right? Makes sense, right? I mean, just in numbers, we were saying image 0 to 100, it was the whole thing. Now we said 0 to 50, it's 50, 50. As far as the extent of the image. Try it again by double-clicking the image sampler right here, and now go back to 100. 1, 0 instead of the 5, 100 instead of the 50. Okay, and it goes back, right? Now it's 0 to 100, 0 to 100. It's a square. Basic dimensioning using Grasshopper and a mesh. Now, again, this height deformation is controlled by this height value over here. If I pick 1 instead of 3.2, 1 enter, that extrusion changes, right? 0, I mean the movement. And I was wrong. The size, the height that these are moving is not controlled by this slider. This slider controls the plane that you see moving there that cuts through the object, right? What controls how much this deforms downwards or upwards is what this person did here. So whatever is getting processed through the image, on the factor for the Z value, he put in 10, move it 10. So if I right click it and find expression, and instead of X times 10, I say X times 5, and then hit commit changes, I'll see half of that, right? So it's just numbers telling me how much things extrude, how much things move, but you're still going back to numbers. It's 5 inches, 10 inches, right? Nothing out of this world, no crazy math. The math is it's being done by Grasshopper. You just have to pick the numbers. Cool, so now you have a different option. You can bake it as well, insert. And that's what Selena was saying. It's like now I made a different option, different height, different model off of the same image. I have 2 iterations in less than 10 minutes of that particular goal, right? Now I care about these curves that are getting drawn. That's the intersection. I'm also trying to get curves and lines out of this as a vector drawing. So those are already being made for me here, okay? Now what I want you to observe is that these lines are a little, right, rough because that's how the mesh looks. Remember the mesh? a little jagged, an approximation of the image. So this is the resolution that we end up with. We have to go back to how many points are in this mesh. It's a lot actually, 220 by 220. Let's just change it to double click and do 300. Let's not go crazy. 300, enter, give it a minute, and you'll see that the shape gets a little more defined, the intersection. More resolution because you added more points, right? So now that we have 300 and that decreasing is less heavy than increasing in Grasshopper, let's zoom into the slider like this, but make sure you have a preview where you can see the shape being generated. So identify that first, click on the section, the last of the Grasshopper items, leave it selected, okay? And then go to where that 300 is and zoom into it, so that you're like actually very close to it, like this. Because the closer you are to the slider, the smoother the control you have to move it. And move it back as you zoom in here too. You see the resolution of the shape. I have all these points added, 900 points, 300 by 300. Sorry, 9,000. And now if you go down, back, I'm using less points, less resolution, less, until I lose what I had, but I created something else that might be of interest, right? It's based off of something, but I generated an alternative design because I removed resolution. So it's,
Abstract.
right, less resolution, still using the same, what? Same radial information, same tangent information, so that you never get out of. You can still BS through your whole, right? Well, not BS. Yeah. You don't BS. I'm gonna have to get that part out of the recording. But now, right, you can basically play off your things, and it's easier to back up the concept. So no, I'm going off of my geometry. It's not abstract at all. I used a transformation that is still based on the same, right? But I changed my circulation, or I changed my space.
Are you gonna use this for that?
I know, we just figured out.
Oh, yeah, I don't even want to know what your assignments are, because then I'll start thinking about what you could use. She knows, right? Anyway, so there you go. And we have 4 minutes left, so perfect timing to go back all the way to the last result again. Hover over the letter C and see that it says the result, in my case, is 43 polyline curves are getting generated. Cool, I'll respect that. And I'll say insert or bake, there. Click away from it, just minimize Grasshopper. Remember, you can't click on anything other than what's baked. So I can confidently grab all of these, move them over here. And determine of all those curves that he said, Grasshopper said I had, okay, I can click on them. They're all nicely closed. What is it? Oh, okay. I'm glad I heard that. Now help me get this into an actual class.
But this is better because you have to do less work once you establish the script or you're using, you know.
Yeah, you can go back to it.
You're like, I want to see it. You can iterate so much more than
Yeah.
just like, you just get tired of modeling back. You know what I mean? You're like, oh, this is taking too long.
And that's one of the primary reasons I ended up getting into it so much. I was already tired of modeling. I'm like, I have to model faster. And now I'm tired of Grasshopper. I need to model even faster, right? But that's what happens. It's like you'll get so fast, and then you need the next big thing, and that's great. Okay, so in the last couple minutes, open Grasshopper again, put it on the side, okay, and here's the last step. We made geometry that is now in Rhino. Grasshopper doesn't know anymore. It doesn't care, right? This is Rhino geometry now. Okay, cool. Let me click on one of them. One of the curves, select whichever one you want. I'll pick the biggest one right here. Okay, it's selected. Rhino says one curve added to selection. Let's go to Grasshopper here. move to where you don't see anything, only canvas space. Double click the canvas. That's like the same as opening a command bar. Once it's there, you can search for things. I'm going to search for curve. There are many curve options, but you want to find the one that's basic. Contains a collection of generic curves. Okay, cool. Click on that. It gives me a curve component that is empty. Hover over the balloon there. It says this object contains one warning. Okay, the warning is there's nothing in it. Okay, good. So click what you want to put into that guy. Right click the parameter and go to set one curve. And click away from it in Rhino. Now when you click on this curve, it'll highlight it. Now it's imported into Grasshopper from Rhino. You could also draw something from scratch in Rhino and then make it parametric, right? It depends on how you work. Okay, so now I have this curve. Well, guess what I want to do now? I want to extrude it. Okay, look for the extrude command. Extrude. There you go. Connect the shape you want to extrude to the B or the input. Always hover over the input first. What is B? Profile, curve, or surface. Base. Okay, perfect. D, extrusion direction. Okay, now I know what it's asking for. Okay, first of all, the profile curve. There you go. It's going to D. Hover over the balloon. What's going on? D doesn't have data. Okay, what does D want? Direction. What direction do I want to extrude? First thing that comes to my head, Z. Okay, I want to go up. Double click the canvas, type in Z. That's the most intuitive thing. Okay, unit Z, vector Z. There you go. So I am going to connect it to the direction component and see that there's a default extrusion going up, right? Hover over F, which is the input for the Z direction. It's saying one locally defined value. That means that by default, Z comes with a 1, right? Just for you to be able to see the change. You can specify any other number going into F by double-clicking the canvas, type in 10, enter. Now you have a number slider that goes from 0 to 10. 0 to 10. You can scroll through it like that. Okay? Leave it at any value, put it on the factor for the Z vector, and you'll see the extrusion growing. Okay? And you can go back and up. Cool. With that, now you've made an object. You can click the extrusion, which is finalized, and insert. Now you've baked that design iteration. Poly surface cleanly made off of those curves. And you have the most beautiful organic floor plan going on, right? So
Wait, how do you, so how do you select this?
which one? Oh, you have to bake it. Remember, if it's red like that, it's still in here. So click on this guy and insert it, or it's there. You'll see the shadow immediately once it's physically in right? So the good thing here to recall always is that more important than everything, because obviously we're not that experienced yet, is just knowing the process, right? This is my playground, and I have this kit of instructions that can do everything I can think of, and I know they're there, but I have to access it slowly, right? I'm going with points and curves and stuff, and I'm going to get to where I need at some point in the future, right? But if I don't stop using it after today, I will discover things. And what I mean by that is that there's always something online. People have been using Grasshopper for a while, right? And it's always in development. It's never been finalized. So guess what happens? I was trying to look up the image sampler. Image sampler, Grasshopper. Type in anything Grasshopper after that, and you'll find so many things. So image sampler, so many options, different examples. You might find the one I used today somewhere here. I mean, they're all the same, right? This person here used the Grasshopper logo to do the same that we just did. I mean, that's right. But you could get very artistic, right? With images, with patterns to perforate. Yeah, you can laser cut these things. You can create a facade of this, blah, 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 right? So obviously I had to really think about, okay, I'll show you the basics, but I was thinking about, and I left it open here, I was like, we're going to build a facade, shading facade today off of Grasshopper, but you would have just run away from here if we had started there. But just bear in mind that the next class will get more into construction of actual objects using Grasshopper. But this is perfect. As a start, get into this off of a script that has already been downloaded from the web, and we managed to, oh, that's using an image. What if I use my image? That's the process that you want to get into. Here's a script online. I'll download it and I'll open it. I'll see what it's doing in Rhino. What if I do my own part of it? And then you get into it. That's how I got into it. I mean, you could have a different experience, but that's just how it goes.
Another thing to remember is, Rhino, you need to save Rhino files and Grasshopper files.
Right.
The Grasshopper is within it, which is where you open it, but you gotta save the Grasshopper file. There's so many ways to reuse the script.
Yes.
So you said save them both like separately?
So yeah, look at this. So first, in Grasshopper, go to File, Save Document As. Just the basic saving as option, and save it as what it's called already. Just save on top of it. Select the type as GHX. You can also do GH, but GHX is usually the latest version. The other one is like a legacy. So let's use GHX. Hit save. It'll say it's going to replace it. I'll say yes. Perfect. And then the Rhino file, now that we've saved Grasshopper, we can confidently click close the script. Totally blank, or give you shortcuts to other scripts you've worked on. Okay, if they're there. You can minimize this and now save your Rhino file, which we know has layers and stuff. They're already hidden, but they're there. So save the whole file as save as. That's funny, we never saved it. We could have crashed. That's bad practice. That's not part of the tutorial. So save your file, Rhino 6. You can go back as far as Rhino 2, but Rhino 6 and name it 01 underscore, or sorry, intent or intent workshop, whatever you want, 01, and there you go. It's the first one we've done. And
Another thing, if you guys could take an image of what the work you've done.
oh, I will. That's why we're getting the, yeah. No, I'll grab screenshots of what you've done to send to Wanda.
No, I'm not sure. So they can learn how to capture it within Rhino.
Oh, okay, yeah.
So you can,
So I just tried to put like an image in and see if I can.
An image inside a Rhino?
Yeah, that's right.
You just did?
Same thing. Yeah. How did-
Oh, yeah, some other image. I see. Well, yeah, the image data is going on from the input, then from the output, because of that. You're just replacing it, but doing the same thing. And don't forget what's going on inside. Let's double click it. The 0 to 100, right? It's by default going to go from 0 to 1. So once you put it on, you'll see a very tiny logo in the whole thing. That's a great thing right there. It's like to experiment with your own image, right? So save all of that, save it all, and we're good.